Welcome to Database Management System series of video lectures. Today we are going to discuss about Unit 1, Topic 5, Levels of Abstraction in a Database Management System. Now, what is abstraction? In general sense, abstraction means that hiding the unwanted details and exposing only the important details. So, in this database management system, abstraction is required because while maintaining the database system, we will construct various complex structures for storing the data. So all these complex data structures need not be understandable by a naive users or a common user who will retrieve the data by accessing to the database. So in order to simplify the interaction with the user, while communicating with the database, the developers have hidden the internal complex data structures from the users. So this process of hiding irrelevant details from the user is called as data abstraction, or presenting only the required details to the users by hiding the unwanted details to the user is called as data abstraction. Now, let us look at this figure to understand what is this data abstraction. So this representation of data is also termed as architecture of a database system. So this architecture is represented in a three-tier level. As we have different levels for looking at the data, we call this picture as levels of data abstraction. Look at here, the bottommost one is called as a database. Here we have taken only single instance of a database. Now this data, physical database can be accessible by using a physical level. The first level of database here is a physical level. Second is conceptual and third is view level. The actual hardware database, how the data is being stored, can be retrieved from the physical level. So from physical level, we will be able to find out what is the structure of data which is maintained internally. That's why it is called as internal schema of the data. Schema here is nothing but a structure or a layout of the data representation in the memory. The second level is called as conceptual level. In this conceptual level, we are just trying to understand what kind of data is being stored in the database. So this data can be viewed at second level, that is logical level. So here the underlying hardware representation of data is totally removed or hidden from the user. So only the logical structure of data is retrieved from this conceptual level. And the third type of level is called as view level or the external level. So here, multiple number of users can interact with the database. Every user can access to the database for accessing different types of tables or different information can be extracted from the table and viewed. So every user will be presented with a different view of data. Let's say that user 1 is accessing hospital data. So only the hospital related data tables are accessed and the data is extracted from those tables and presented to the user. And user 2 is trying to access a department information. So only the department data is accessible from the database, and what set of elements that have to be viewed, only those are displayed to the user too. So similarly, for various types of users, different views are going to be presented. So if there are any modifications that are made from the user from view level will not have a direct impact upon the underlying architecture, right? So now, the same thing I have explained to you here. Physical level. What is physical level? Physical level represents the lowest level of data abstraction. It focuses only on how the data is being stored. So it is going to maintain a complex data structures for the maintenance of the data. Second is logical level. This is the middle level, and this describes what type of data is being stored in the database. And the third one is view level, which is also called as external schema, which represents highest level of data abstraction. So this level describes the user interaction with the database system only. It totally does not bother about how the data is being stored and what type of data which is being stored. Now we have explained the same thing with an example. You can go through this example, how the data is being accessible by the named users from the underlying architecture of the database. So at the physical level, we just try to look at the data in terms of blocks of memory, how the data is being stored, how many bytes have been consumed, which disks are used for the storage of this data. So all these details are hidden from the programmers. Programmers need not bother about where the data is being stored at which particular memory location. And at the logical level, only the data can be viewed in terms of records, fields, and attributes, and which type of data is used, and what is the relationship which is maintained from one table to the other table. Only the logical relationship from one element to the other element can be retrieved or can be seen from this level. And the third type of level is view level. Here, just the user interactions are made either in terms of command prompt, that is character user interface, or with the help of GUI, that is graphical user interface. So here at the view level, the user is completely abstracted from the data, how it is being stored and what it is being stored. Next topic is data independence. With respect to this three-tier architecture, we will be able to explain that how data is completely independent from one level to the other level. To have better understanding of it, this data independence has been explained with the two different types. One is logical data independence and the second is physical data independence. What actually a logical data independence is? Logical data independence tells that we will not be able to change the underlying storage of data elements with respect to the conceptual data manipulation, which means that if we do change or manipulate any data elements at the conceptual level, will not have any impact upon the underlying storage of data. And the second one is physical data independence. If the storage of data at the memory blocks is modified, it will not have any impact upon the conceptual data or the logical view. So the underlying changes will not have any impact upon the actual data, and the changes to the actual data will not have any impact upon the physical storage. So with this, we will be able to achieve physical data independence and then logical data independence. If there is any change that is taken place at the topmost levels of abstraction, will not have any impact upon the physical memory. If the changes in the physical memory has been made, will not have any impact upon the actual data which can be viewed from the conceptual level. Right? So this will be the end of the concept. Thank you.